Alright, so in this video we're talking about linear inequalities in two variables. Before, in chapter 1, we talked about linear inequalities in one variable. So we're stepping it up a little bit. Okay, so what's a linear inequality? Well, it's something where our boundary line is going to be a straight line. So we have and it's going to look something like this. So y greater than mx plus b. Could be less than or greater than or equal to or less than or equal to, but it's going to be something like that. So instead of equals, we have an inequality symbol, and we have two variables. And what is a solution? Well, now it's going to be an ordered pair. An ordered pair that satisfies the inequality. That satisfies the inequality. So we want to check whether or not these 3 points satisfy the inequality. In other words, we're checking these 3 points right here behind me. Are they solutions for this inequality? So all I'm going to do is, everywhere I see an x, I'm going to just plug in x, y, x, y, x, y. And I'm going to do this one at a time. So for the first one, everywhere I see an x, I'm going to put in a 0. Everywhere I see a y, I'm going to put in a 1. So this is pretty easy. So 2 times 0 is just 0, so I don't need that. 3 times 1 is 3, so it's 3 greater than or equal to 5. That is not a true statement. That is not a true statement, so cross it out. So no, not a solution. So not a solution. Okay. Next, try it again. So 2 times 4 is 8. 3 times -1 is -3, greater than or equal to 5. Now 8 minus 3 is 5. So 5 greater than or equal to 5. That is a true statement. So yes, 4 - 1 is a solution to this inequality. And then finally the last one, 2 times 2 is 4, plus 3 times 1 is 3, greater than or equal to 5. Just simplify it a little bit. So we have 7 is greater than or equal to 5. And that's also a true statement. So yes, the ordered pair 2, 1 is a solution for this inequality. And that's all it is. That's how I call these test points. You're testing, does it satisfy, is it a solution of the inequality? What does the graph of linear inequality look like? Well, we're going to have our boundary line, and then we're going to shade on what side of the boundary line gives us a true statement. Okay, so it's going to be a boundary line. And shade the true side. In other words, we're going to shade the side of the boundary line where all the points are solutions. Okay, so a boundary line is just what would the linear equation be if instead of an inequality, we use an equal sign. So it's just a straight line. Okay. Now that boundary line may or may not be included as part of your solution set. If it is included, you're going to use a solid line. If it's not included, you're going to use a dotted line. Okay, a half plane. Well, a half plane is just this half of the grid that's split up by the boundary line. So half of the grid split up by the boundary line. And then how do we create a graph first? What we're going to do is we're going to graph the boundary line. We're going to graph the boundary line, and then we're going to pick a test point. Okay, our test point cannot live on the boundary line. Okay, so you want to also pick a nice point. Typically 0, 0 is nice if it doesn't live on the boundary line. If it does live on the boundary line, pick another nice point like 1, 1, 2, 1, something nice that's easy to work with. Okay, so pick a test point. So test a point. And what you're trying to find is it a solution of the inequality? Just like we did on the previous slide with those previous problems when we were testing points. Is it a solution to the inequality? If it is, then you shade that side where the point lives. If it's not, you shade the opposite side. If yes, solution, then shade. Otherwise, shade the opposite side. Otherwise, shade the opposite side. Okay, so let's do an example. Example speaks 1,000 words. So we actually have two problems here, and we want to graph these. I have y less than 2. Do this one at a time. So just like with equations, anytime you see y inequality symbol number, that means we're looking at a horizontal line. So our boundary line is going to be horizontal. And so it's going to go through the point 0, 2. And it's going to be a horizontal line. Now, it's less than 2, so we know that the boundary line is not included, so I'm going to use a dotted line as my boundary. And I'm looking for all the values that make this true. So I'm going to test the point. So 0, 0 is right here below the boundary line. I'm going to test that. Well, everywhere I see a 0, everywhere I see a y, I'm going to plug in a 0. 0 is less than 2. That's a true statement. So I'm going to shade beneath the graph. Okay? So shade, 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 shade. Okay? So all of this is the half plane that represents the solution set. This is up above the boundary line. This is the half plane that represents the non-solutions, or the points that do not satisfy the inequality. All right, let's go into the other one. So x is less than or equal to 1. Now, just like with equations, anytime you see an x and a number, that just means a vertical line. So here our boundary line is going to be vertical. Okay, so I'll go out to x equals 1 right here. I'm going to do now, it's less than or equal to, so that means my boundary line is included in the solution set. So I draw a solid line. And again, I want to test the point. Well, 0, 0 is pretty nice, and it's not on the boundary line, so I can test it. So everywhere I see an x now, I'm going to put in a 0. 0 is less than 1, so everything on the left of my boundary line, where 0, 0 lives, is part of my solution set. So all of these things over here are part of my solution set. Okay? So here to the left of the boundary line is the half plane that represents my solution set for this inequality. To the right of the boundary line represents the half plane where these points do not satisfy the solution set. Okay? Let's try a little bit more difficult. So here I have two equations. I'm going to do the first one in red. So I have y is less than 2x. Well, first thing I want to do is graph the boundary line. First thing I need to notice is that, hey, my y-intercept is 0, 0, 0. So I can't test that point, okay? I can't test that point. And my slope of the boundary line is 2. So I go up 2 and over 1, just like we talked about. And my boundary line is not included, so I'm going to draw a dotted line. Okay? So my boundary line looks something like that. So now what I want to do is test the point. Well, 0, 0 lives on my boundary line, so I need to test the point. So instead I'm going to try 1, 0, 1, 0 right here. I'm going to test that. So everywhere I see an x, I'm going to plug in a 1. Everywhere I see a y, I'm going to plug in a 0. So I have 0 is less than 2. That's true. So this test point worked. That checked out. So I know that my solutions live on this side of the boundary line. Okay. So down here is the half plane that represents the solution set that works. This is the half plane that represents all the points that do not satisfy that inequality. I want to do the other inequality in blue. So 2x minus 5y is equal to 10. Okay. Well, here I need to first, it's probably going to be a little bit easier for me to graph this if I get it in y equals mx plus b. So I need to get y by itself. So doing a little bit of work first, I have negative 5y is greater than or equal to 2x, negative 2x plus 10. Still need to get y by itself, so I have to divide by a negative, so that y is less than or equal to, because remember, when you divide by a negative on both sides, you got to split that inequality symbol. So positive 2/5 x minus 2. Okay, so my y-intercept now is at negative 2, and my slope is 2/5. So I'm going to go up 2 and right 5. So up 2 and right 5. So here's my next point. Now also notice that my boundary line is included in the inequality. So I'm going to draw a solid line. So something like that. And I want to test the point. Well, now 0, 0 does not live on this blue boundary line, so I can test it. So everywhere I see an x, I'm going to put in a 0, and everywhere I see a y, I'm going to put in a 0. So 0 is less than or equal to negative 2. Well, we know that's not true. That's false. So since it's false over here where 0, 0 lives, I'm going to shade on the opposite side of the boundary line. So that means I'm going to shade over here. So all these points over here satisfy it. Okay, and that's it. And that's it for graphing linear inequalities in two variables.